In this video, I'm going to talk about solving system of equations algebraically instead of graphically. So there's two methods to solving system of equations. One of those methods we already talked about, which is graphing, and the other way is to algebraically solve. So by graphing, you find the point of intersection, or you can algebraically solve. So if I algebraically solve, there are two methods I could use. So I could either use, I could use substitution, or I could use elimination. Those are two different methods, and you can choose whichever one you like best, but I'm going to go over both. For substitution, the first step is to solve for one of the variables. So there'll be two variables usually, and you'll solve for one of the variables. So solve for just one of the variables. You won't be able to get a number for it, but you'll get an expression for it. So you can do that for either x or y. Usually you'll be dealing with x and y. After you solve for one of the variables and you get an expression in terms of the other variable, you're going to substitute the expression into the other equation. So for the first step, you're just going to pick one of the equations in the system, and you're going to use that one to solve for one of the variables. Then you'll substitute whatever expression you get into the other equation. After you plug the expression into the other equation, you're going to solve and get a number for the variable, and you're going to take that variable, plug it into whichever equation you want to solve for the variable you don't have. So you're going to solve and plug in the variable you solved for into one of the equations, whichever one. To solve for the other variable. Okay, so let's do an example. If we look at this example 1, this system, to solve this system by substitution, I'm going to solve for one of the variables by itself, either x or y. Well, I already have one of the variables by itself. The expression that it's equal to is y plus 1. So what I'm going to do is take the other equation, so x plus y is equal to 5, and instead of x, I'm going to substitute in y plus 1. So instead of x, I'm going to substitute in y plus 1. Then I have y plus 1 plus y is equal to 5. From there, I can collect my y's, so I have 2y plus 1 is equal to 5. I'm going to subtract 1 on both sides. I'll get 2y is equal to 4. I'm going to divide both sides by 2. And I'm going to find that y is equal to 2. So I've got what y is equal to now. Now, I'm not done yet because I still need to know, for me to find the solution, I need to know x and I need to know y. I need to know a point. And right now I just have the y value, so I just have this y value. What I'm going to do is I'm going to pick whichever equation I want. I'm going to put, I think this one's easiest, and I'm going to plug in y is equal to 2. So I have x is equal to y plus 1 is the equation I'm going to use, and I'm going to plug in that y is equal to 2. So y is 2. I get x is equal to 3. So I have x is 3, y is 2. The solution to this system is 3, 2. That's my solution. Looking at example 2, I want to use the substitution method to solve this one. The first step is to get one of the variables by itself. This equation here is probably the easiest for me to do that with because I have an x by itself, and all I'll have to do is move the 2y to the other side. So I'm going to take this equation, 2y plus x is equal to 1, and I'm going to solve for x by itself. So I'm going to subtract 2y on both sides, and I'll get x is equal to 1 minus 2y. This is the expression, 1 minus 2y, is what I can substitute into the other equation for x. So I have the other equation is 2y minus 2x is equal to 12. That's the other equation. I'm gonna, instead of x here, I'm gonna put 1 minus 2y. So I'll have 3y minus 2 times 1 minus 2y is equal to 12. From there, I'll have 3y minus, I have to distribute this 2 to everything inside the parentheses. I'll have 2 plus 4y is equal to 12. I'll have, collecting my y's, 7y, that's not how you do y, minus 2 is equal to 12. I'll add 2 on both sides. 7y is equal to 14, and that means when I divide both sides by 7, y is equal to 2. So I've got y is equal to 2. That's one of my variables solved for. And I still need to know what x is. So I'm going to take one of the equations that I have, and I'm going to plug in y is equal to 2 and see what I get for x. The easiest one to do that with is the rewritten form of that original equation. So I'm going to use x is equal to 1 minus 2y, and I'm going to substitute in y is equal to 2. So I have x is equal to 1 minus 2 times y is 2. X is equal to 1 minus 4, so x is equal to negative 3 is what I get. That means my solution is negative 3, 2. The other method of solving a system of equations algebraically is to use elimination, and the goal of elimination is to eliminate. So we want to eliminate one of the variables. We're going to eliminate one of the variables by adding the two equations in the system together and creating a new equation. So in order for me to be able to cancel one variable by adding the two equations together, I'm going to need the same coefficients with opposite signs for one variable. So the same coefficients with opposite signs. Okay, so let's look at this example. If I want to solve this system by elimination, I'm going to need to be able to eliminate one of the variables, either y or x, by adding these two equations together. If I add these two equations together as is, I'm not going to be able to cancel anything. I don't have the same coefficient opposite sign for y. I don't have the same coefficient opposite sign for x. When I add this together, I'll get 5y minus x is equal to 13. And that doesn't eliminate any variable for me. I can only solve an equation that only has one variable. I can't solve when there's two unknowns. And I want to be able to get a number for these variables. So what I'm going to have to do is I'm going to have to manipulate one of these equations. The easiest one for me to manipulate is the top equation. If I change the top equation and I multiply it by 2, everything in the equation by 2, I won't have to do anything to the bottom equation, because when I distribute this 2, I'll have 2 as the coefficient for x, which is opposite of -2. So let's rewrite this new equation that we'll get. The new equation that we'll get is, we'll have 4y plus 2x is equal to 2. The bottom equation we're just going to transfer over. We have 3y minus 2x is equal to 12. Now, if I add these two equations together to create a new equation, I'm going to have 7y, 2x plus -2x becomes 0. These cancel each other out. And on the right-hand side of my new equation, I have 2 plus 12, which is 14. So I have 7y is equal to 14. And I can now divide both sides by 7. And I will get y is equal to 2. So I have y is equal to 2. Y is equal to 2. Whoops. And I still need to solve for what x is. So I need to pick one of the equations to use to plug in y is equal to 2 and see what I get for x. I think I'm just going to use the top one here. I have 2y plus x is equal to 1. I'm going to plug in y is 2. So I have 4 plus x is equal to 1. I'm going to subtract 4 on both sides and get that x is equal to -3. So my solution is -3, 2. In case it's a little confusing because you've never added equations together before, we can look at these two equations again. I have, 4y plus 2x is equal to 2, and then I know that 3y's minus 2x's is equal to 12. So I could say, I have 4y plus 2x, it is 2, it's worth 2. 3y minus 2x is worth 12. So if I add these together, I have 4y plus 2x. If I wanted to add 3y minus 2x, I know that this is worth 2, and this is worth 12. So it would have to total to 14 if I added these two expressions together.